Hello everyone. So today we're going to go over the Unit 1 Topic 3 review. This is the video version of my solution key. So the first thing I want to do is I want to factor. So to do that, we need to move everything to one side. So we have ax squared plus bx plus c is equal to 0, right? So we have a quadratic. So right now we have two sides, and I want to move the negative 4x and the positive 15 to the left-hand side. So to do that, we need to do the inverse operation. So the opposite of subtracting by 4x is to add by 4x. The inverse of adding by 15 is to subtract 15. And don't forget to set this equal to 0. So that is the first step. The second step is to set up our factors. Because this is a quadratic, is going to factor to something like this. I'm setting up two pair of parentheses. And I know that 3, the only way to get 3, factors of 3 is either 3 and 1 or 1 and 3. Because these are the only combinations, I typically put the 3 in front. So 3 goes here and 1 goes here. Right? And because it is 3x squared, it should be 3x and 1x. But we typically don't put the 1x, so we would represent it as x. And then we have the 15. So technically it's a negative 15, but I just care about the positive 15 for now. So the combinations to get 15 would be 1 and 15, 3 and 5, 5 and 3, and 15 and 1. We should always check the middle first. It's very unlikely that your teacher will give you 1 and 15 or 15 and 1. So what I want to do is I want to check 3 and 5. So suppose I want to check 3 and 5. This is automatically a wrong guess because 3 and 3 have a common factor. They have a common GCF, meaning they're both divisible by 3. So we should not do that. In fact, we can guess this and check it. We take a look at the outers and the inner layers. So 3x times 5 is 15x. And 3 times x is 3x. There's no way that we can subtract these or add these to get 4. Right? The difference is too big. 15 minus 3 is 12. So this is not a good guess. So we know that 3 and 5 is not good. So now we try 5 and 3. We multiply 3 times 3, so the outer, that is, 3x times 3 is 9x. And then 5 times x is 5x. So we can somehow get 4x, right, by adding or subtracting these. We can actually subtract these. 9x minus 5x is 4x. So we want the 9 to be positive. So what that means is that this 3 has to be positive because 3x times positive 3 is 9x. And we want this to be negative because negative 5 times x is negative 5x. So that is how we factor by guessing and checking. So after you have completely factored it, we need to make sure that we solve it. So I'm going to recopy down the problem, and I will set each factor. So this is the factor, and this is a factor. We set them both equal to 0. And the reason why we do this is because any number times 0 is 0. So here we need to, on the left side, we need to add 5, inverse operation. And then the opposite of multiplying by 3 is to divide by 3. So x is equal to 5/3. On the right-hand side, we just simply subtract 3, and we get that x is equal to negative 3. For 1b, we're going to do the same process. This time, I will move the negative 16x squared to the left-hand side. So to do that, I need to add it to both sides. And I will actually add it like this. I put it in front. I still have the 40x and the 25. And because we don't really need that plus sign, we can get rid of it. So this problem looks difficult, but we need to recognize that 16 is a perfect square, which means that 4 squared is 16. And 25 is like saying 5 squared, right? And x squared is also a perfect square, which means x squared is x times x. So this problem is kind of nice, right? So like if you had to crank it all out, 16, the only way you can get 16 is either 1 and 16, 4 and 4, right? 2 and 8, 8 and 2, right? 16 and 1, lots of combos. But it's very natural to look at 4 times 4, right? So to set it up, if we factor it, it should be like 4x, 4x. And normally to get 25, right, you're naturally thinking about not 1 and 25, I hope, but more as 5 times 5 or 25 times 1. You should guess the middle ones, like 5 times 5. And if you guess that, this should be correct. Let's erase this work here. Outers, 4x times 5 is 20x, and 5 times 4x is 20x. And these two add up to 40, right? So therefore, this is a plus sign and this is a plus sign. Because we want these to both be positive to add up to 40x. So we have that. And after we have factored it, don't forget we have to solve it. So here we're setting each factor equal to 0. But notice that this is the same thing as saying 4x plus 5 squared equal to 0. This is also known as a perfect square trinomial. So what we can do is we can square root both sides. Right? We could do that. That's like an extra step. But the square root of 0 is 0. So now we just simply subtract 5 from both sides. And then we divide by 4. So that is our solution. For number 2, we are now doing the polynomial long division. Our denominator is x squared minus 2x minus 3. And our dividend, which is the numerator, is x cubed plus x squared minus 9x minus 14. Please make sure that they are in standard form, meaning it goes 3, 2, 1, x to the power of 0, right? It has to be in standard form when we do the long division. Whoops. Let me just recopy that down. And we have so. So the first thing you want to do is you want to look at the leading terms, x squared and x cubed. So let's do the work on the side. X cubed divided by x squared is x. Because 3 minus 2 is 1. It's like saying x to the power of 1, which is simply x. So this goes on top. That is x. So let's erase that. And you need to show your work. You're multiplying x times x squared minus 2x minus 3. Right? You're distributing that x. So x times x squared is x cubed. Right? So we need to subtract. And notice how there are 3 terms here. Because there are 3 terms, we need to put the parentheses after 3 terms. 1, 2, 3. All right, so we have x cubed goes here. It has to be the same to cancel out. We have x times negative 2x, which is negative 2x squared. So negative 2x squared goes here. And then we have, last but not least, x times negative 3, which is negative 3x. So this is going to be minus 3x. And we subtract them. So this must cancel out. X squared minus negative 2x squared. So that's like the inverse of subtraction, which is addition. So that means it's x squared really plus 2x squared. So that gives us 3x squared. This will be negative 9x minus negative 3x, which is like saying negative 9x plus 3x, which is negative 6x. And we need to make sure that we drop down the negative 14. So we drop down the next term, and we repeat this process again. So now we need to do on the side 3x squared divided by x squared. So that's like saying 3x squared divided by 1x squared. This cancels out, and we're left with 3. So this is going to be plus 3. That goes on top. And we repeat that same process. We take 3, we multiply to x squared minus 2x minus 3. So 3 times x squared is 3x squared. 3 times negative 2x is negative 6x. And then 3 times negative 3 is negative 9. So we subtract 3x squared minus 6x minus 9. When we're subtracting and the terms are the same, they just cancel out like this. And we just simply have negative 14, right, minus negative 9, which is like saying negative 14 plus 9, which gives us negative 5. And when you're done, make sure that you write down the solution, right? The solution is equal to x plus 3, that is our quotient, this guy, plus the remainder, which is the leftover, negative 5, all over our divisor, which is the stuff in red, x squared minus 2x minus 3. And that is our final answer.